Alright, so here is friction. I'm going to call this thing number 4. It's the fourth example that I put up here, but I have it listed as being difficult or advanced. It's not that it's more advanced. The processes are all the same, but obviously if you don't know how to do something, it seems advanced. But either way, so this is the example. We've been working off a couple of the problems. We got ourselves up, let's go with the 5 kilogram box. And at this point, we're going to follow the same rules that we always follow. Number one, let's label the forces. Um, and then number two, break your into X and Y components and just see what's going on in each component. And then three, simply solve for what you want. Um, so what I'm going to do is take this box and I'm going to lift the board that it's on. I'm going to lift it and I'm going to form some angle here, and I want to know at what angle does the box start sliding down this thing. So I have an angle here and 5 kilograms. I'm looking for this particular angle right here. So part of labeling all your forces is make sure you get a picture that accurately represents what you want. And if that picture is deceiving you, then you're going to have some issues. Um, so we have a 5 kilogram box here, and what all is going on? Well, I have my force of gravity that's pulling down. I have, in this case, I'm going to draw my components right away. Because I'm not in line with gravity, I have a component this way, which is, I'm going to call this is my, I'm going to call my X direction. This is my Y direction, just FYI, so you know what I'm looking at here. This is my force X, and then I have a resulting component as well in the force Y direction. And this is my angle that I am looking at. I have, so this right here is the force in the X direction. I have this force right here is my force normal, okay? And then I have this as being my force of friction. Okay, so a few things that you might just want to note here. Let's list all variables out. Force of gravity, which equals to mass times acceleration, which because the mass is 5 kilograms and the acceleration is 9.8, that's 49 newtons. So F of G is 49. We have the let's go ahead and just let's do a couple of things first. The force of friction equals the coefficient of friction times the force normal, and I'm going to go with, just so you know, the coefficient of friction equals 0.3. Just kind of lay that out there for now. I set this value from the start. You have to have that for this particular problem. And then the force normal, just FYI, the force normal is just going to equal the force in the X direction. They're going to balance each other. All right. So let's take a moment to get the F of X and the F of Y. I'll do that right here. We have our angle looking like this, a little bigger, and this is my right triangle here. This is 49. This is my angle, which I don't know what it is. So in this case, I'm looking for, this is my F of X. This is my F. I have it labeled backwards here. Let's go, because I'm in X here, we'll call it X, and we'll just say this is Y. And therefore, my force normal, it will equal my F of Y. And just to make sure I follow my original pattern. So in this case, okay, for my X, the cosine, and so it's upside down here, the cosine of the angle is equal to my adjacent over my hypotenuse, and the cosine of the angle, therefore, and the hypotenuse is 50, and my adjacent is f of y. So cosine of the angle times 50, actually it'd be 49. Yep, it's 49, as I labeled here, 49. So I don't know why I flipped back to the original mass, but that's 49, equals f of y. All right, f of y. Cosine is the adjacent angle. Now the opposite angle here is the let's go opposite, so sine of the angle equals the opposite over the hypotenuse. In this case, the hypotenuse is f of x, and this is going to be 49 newtons, and this is going to be my angle, which I don't know. So sine of the angle equals times 49 equals f of x. So f of x in this case, let's just relabel them here, is going to be sine of the angle times the 49, and then the f of y is equal to the cosine of the angle times the 49. And that is, I don't know the angle, I would put that in there. That's kind of what I want to find. All right, and so I have each piece here. The force normal is the coefficient of friction times this guy. So let's rehash the force of friction here. So everything's here. The force of friction, okay, is equal to the coefficient of friction times the force normal. The force normal equals f of y. Okay, that's where I made that typo earlier. So the force normal equals f of y. These two are balanced. Okay. So f, in this case, force normal equals f of y. F of y equals the cosine of the angle times 49. Okay. So all my forces are labeled here. Now let's just take a moment and let's look at my x and y components and just see what we all have here. Now in the y component, we did allow this already. Okay. The box is not leaving the surface. So I have balanced forces. My force, in this case normal, equals the force that's opposing it, which is the component of gravity. This is going to be the f of y, and f of y, as mentioned, by solving for this leg right here, is the cosine of the angle times 49. Okay, times the cosine of the angle times 49. All right, so that one's done. And then the x component has a couple things involved. In this case, we want to tip it so that it's just about to move, or it's just anything more angle, it will move. So basically, want to say, what is the force where both these are equal? So at this point, my force of friction, okay, equals my force in the x direction. Again, make sure you see your picture. These two are equal. So the box currently is not moving. In any of this picture, it's not moving. So let's resubstitute what f of x is, because we don't know exactly what it is. So the force of friction equals f of x. F of x is equal to the sine times 49. So f of x equals the sine of the angle, okay, times 49, okay. Oops, that's 49 newtons. Okay, and the force of friction is the coefficient of friction, right, times the force normal, right, which of course equals f of x, which is sine of the angle times 49. All right, so now let's resubstitute in what f of n is right here. The finally come to the end, coefficient of friction is times force normal, which is f of y, times the coefficient, the cosine of the angle 49, equals the sine of the angle 49. Okay. At this point, all I have left here, and this is f of y, so that's not there. And this is equal to f of y, so all the way down here, all we have left here is the coefficient of friction times the cosine of the angle times 49 newtons equals the sine of the angle, 49 newtons. Coefficient of friction, solving out for this angle, is equal to the sine of the angle. Now the 49s are on both sides, so they will cancel. Divided by the cosine of the angle, and the coefficient of friction is given the problem at being 0.3. That is given right here, 0.3. And at this point, this equals the tangent of the angle. So 0.3 tangent of the angle. And the inverse tangent, solve for that. And we get an answer of 16.6 degrees. And that is my angle. Anything beyond that, and it will be sliding. Now, important to point out here that anytime you want a coefficient of friction, it is simply your tangent of the angle. So if I have an angle, any surface, okay, and you put it just barely starts to slide or just isn't sliding, that angle right there, you take the tangent of that angle, theta will equal your coefficient of friction. Quick recap, I know there's a lot of dominoes falling here, but the picture should explain what's going on. We have these two forces equaling, okay, the f of x, let's put the numbers in here, f of x, okay, of course, is going to be a component of the actual gravity. This is the sine of the angle times 49, that is this guy. The force of friction is the coefficient of friction times f of y, the force normal, okay, which is going to be equal to coefficient of friction times the cosine of the angle times 49, and that ultimately is what we get to solve this out. The force normal simply equals the force of y. In that case, the force of y is cosine of 49, which we already used. Okay, that's pretty much it. Again, a little more complicated problem, but all we're doing at this point is drawing a picture and then looking at x and y components and solving for what we need. The real challenging part here, I guess, would be knowing that we need to use the tangent function as a resolving feature mathematically. Thank you.